All right, let's talk about what might just be the single most important scientific book ever written. We're diving into Isaac Newton's Principia Mathematica, and this isn't just some old book full of answers. No, this is the book that completely changed the kinds of questions we even knew we could ask about the universe.
And hey, don't just take my word for it. The legendary mathematician Joseph Louis Lagrange called it the greatest production of the human mind. That's not just high praise, that's about as big a compliment as you can get. It really sets the stage for how much of a game changer this was.
And here it is, Philosophia Naturalis Principia Mathematica, or the mathematical principles of natural philosophy. Now, you're looking at something from 1687. It's written entirely in Latin, it's incredibly dense, not exactly light reading. But inside these pages, Newton basically built the foundations of what we now call classical mechanics. He completely redrew the map of the cosmos.
But you know what's funny? This massive, world-changing book, this pillar of science, it didn't start with some grand vision. Nope. It all kicked off because of a friendly chat, a persistent question, and, believe it or not, a bit of a bet.
So here's the scene. It's January 1684. You've got three of London's brainiest guys, Edmund Halley, Christopher Wren, and Robert Hooke, arguing about why planets move in these specific oval shapes, these ellipses. Hooke boasts that he's figured it out, that he has a proof, but he never actually shows it to anyone. So a frustrated Halley decides to take a trip to Cambridge to ask this reclusive genius, Isaac Newton. And Newton's response is just amazing. He basically says, "Oh yeah, that. I solved that years ago. I just seem to have lost the paperwork." A few months later, though, he sends Halley a 9-page paper that proves it. And Halley reads it and his mind is just blown. He knows, right then and there, this is too big to stay on some dusty shelf.
Now, of course, Newton didn't just pull this out of thin air. He famously said that he stood on the shoulders of giants. You had people like Copernicus, who'd already put the sun at the center of the solar system, and Galileo, who had laid out the basic rules of motion and inertia. All the pieces were kind of floating around. Newton was the one who saw how they all fit together into one incredible, unified picture.
And that whole picture, that whole grand system, was built on one single, shockingly simple idea. An idea that connected something as ordinary as an apple falling from a tree to the path of the moon in the night sky.
And this is it. This is the heart and soul of the Principia, universal gravitation. I mean, just pause and think about how wild that concept is. It's not just that things fall down here on Earth. It's that every single particle in the entire universe, you, me, this planet, the most distant star, is pulling on every other particle, and all of that chaos is governed by one single elegant mathematical equation.
The amazing part is, this wasn't just a hunch. He proved it. See, before Newton, the astronomer Johannes Kepler had brilliantly described how planets move. He figured out they travel in ellipses, but he had no idea why. Newton, using this new kind of math that he had literally just invented, what we now call calculus, showed that Kepler's laws weren't a coincidence. They were the unavoidable outcome of his law of universal gravitation.
And this, right here, is the insight that changed everything. The force that makes an apple drop to the ground is the exact same force that grabs hold of the moon and swings it around the Earth. The same force that keeps us orbiting the sun. Suddenly, heaven and Earth weren't two different realms with two different sets of rules. It was all one universe governed by one law.
And once you have that one law, its power to explain things is just mind-boggling. All these deep cosmic mysteries that had stumped humanity for thousands of years, suddenly they started to make sense.
You have to remember, the going theory at the time, from the philosopher Decoded, was that planets were being pushed around by these giant, invisible whirlpools in space. But that theory had problems, like it couldn't explain how comets could just slice right through these supposed whirlpools. Newton's idea of an invisible force pulling things from a distance, it sounded weird, almost magical. But it had one huge advantage over the old theory: it worked perfectly. It could predict what the heavens would do with stunning accuracy.
And then the dominoes just started to fall. Why do planets move in ellipsis? Gravity. Why do the oceans have tides that rise and fall? It's the gravitational pull from the moon and the sun. Why does the Earth have a slight wobble that creates a 26,000-year cycle? The moon's gravity tugging on it. The weird wobbly path of the moon, the paths of comets, check, check, check. All of it was explained. One law gave us a universe of answers.
This work is so fundamental to who we are that in 1977, when we sent the Voyager spacecraft out into the cosmos as a kind of message in a bottle, we included a diagram from the Principia. It was our way of saying to anyone or anything that might find it, "Hello from Earth, we figured out the rules of the universe."
But here's the thing. The greatest legacy of the Principia might not even be all the answers it gave us. It might be the powerful new method it taught us for finding answers. It gave us a whole new way to think.
He actually laid out these rules. Rule 1, basically, don't make things more complicated than they need to be. Go with the simplest explanation. Rule 2, if you see the same effect, assume it has the same cause. Rule 3, if something happens in all your experiments, you can assume it happens everywhere. And Rule 4, which is crucial, your experimental results are true until another experiment proves them wrong. Does that sound familiar? It should. It's the blueprint for the modern scientific method. He didn't just give us physics, he taught us how to be scientists.
And that reputation has held up. More than 100 years later, another titan of science, Pierre-Simon Laplace, pretty much said the same thing as Lagrange, calling the Principia preeminent above any other production of human genius. It really did create the science of physics as we know it.
So what's a legacy like that worth today? Well, if we're talking cold hard cash, a first edition of the Principia sold at auction back in 2016 for $3.7 million. That made it the most expensive science book ever sold. It's a pretty clear sign of just how valuable this thing is to our culture.
So, you see, the Principia is so much more than just an old book. It's a cornerstone of the modern world. It's proof that one person's burning curiosity can truly change everything. Newton gave us the tools and the rulebook for understanding the universe, which leaves us with a really exciting question. What will we discover with them next?